You know, there's a revolution happening on factory floors right now, but you probably can't even see it. That's because it's a revolution of sight, giving machines a kind of superhuman vision. We're talking about artificial intelligence that lets them inspect products with a precision and speed that honestly used to be pure science fiction.
So, to really get why this is such a huge deal, we first have to talk about a massive problem that pretty much every manufacturer on the planet faces: tiny, practically invisible defects that can cause some really big consequences.
And just how big is this problem? Well, in super complex manufacturing, think semiconductors or advanced electronics, where every little piece is microscopic, the defect rate isn't just a few percent. It can be just shockingly high, sometimes hitting a mind-boggling 90%. That means the vast majority of products get thrown out. It's an incredible amount of waste and lost money.
Yeah, and this quote from the European Commission just hits the nail on the head. We're not talking about a dent you can spot from across the room. We're talking about microscopic little changes in materials or processes that a human inspector would never, ever see. And yet, just one of those tiny errors can tank an entire production run.
So that's the big question, right? How do you solve a problem you literally can't see? Relying on people to do it is expensive, it's slow, and honestly, it's just a recipe for errors. Let's be real. People just can't maintain that level of intense focus, spotting invisible flaws hour after hour, day after day.
And this, right here, is where AI steps in. It offers a solution that's kind of poetic, really. It gives these machines a form of superhuman vision, letting them see the unseen and just tirelessly watch over production with perfect focus, 24/7.
The technology at the heart of all this is called object detection, and what it does, really, is learn to do three simple things incredibly well. First, it detects that an object is even there in an image. Second, it localizes it. It draws a neat little box right around it. And third, it classifies it, telling you exactly what that thing is.
A really good way to think about it is like this. We're teaching a computer to play a super fast, really high-stakes game of I Spy. But instead of looking for, something yellow, it's hunting for a misplaced screw, a specific tool that's out of place, or even a microscopic crack on a circuit board, all while it's whizzing by on a conveyor belt.
So how in the world does a machine learn to see like this? Well, it's not magic. It's a pretty fascinating process that all comes down to two fundamental ideas working together.
Okay, so the first step is what the experts call the backbone. You can think of this as the AI's visual cortex, the part of its brain that's learning to recognize all the basic features, like lines, textures, and shapes. The second step is region selection, which is basically a spotlight. It tells the AI where in the whole picture it should focus its attention to find something interesting.
All right, let's dive into the building blocks and see how this all comes together, starting with that really important visual cortex, the backbone of the AI.
So the foundation for almost all modern computer vision is something called a convolutional neural network, or a CNN for short. The way it works is by processing an image in layers. The first layers might see really simple stuff like edges and colors. Then the next layers combine those to see textures and patterns. And the deeper layers put those together to recognize complex objects, like a person's face or a finished part.
Now, a huge leap forward came with this brilliant innovation called the shortcut connection, which was pioneered in models like ResNet. Now, it uses some standard processing steps, but the real genius is this shortcut. It lets information literally skip over layers. This solved a major problem and allowed these AI brains to get incredibly deep and powerful without getting all confused, which just supercharged their ability to learn.
Okay, so remember that spotlight? How the AI knows where to look? Well, there are basically two main ways to do it. Think of the two-stage methods like a detective who first cordons off the whole crime scene and then goes in to carefully examine the evidence. The one-stage methods, they're more like a flash flood. They just cover the entire area at once to find everything in a single lightning-fast pass.
And that flash flood idea perfectly illustrates the whole philosophy behind one-stage models, especially the most famously named one, YOLO, which stands for You Only Look Once. Its entire goal is just to be blindingly fast, which makes it absolutely perfect for real-time analysis on a fast-moving assembly line.
Okay, so the tech is cool, right? But the really crucial part isn't just the clever algorithms. It's what this AI vision can actually do when you put it to work inside a real factory for real people.
The applications are incredibly broad, but they pretty much all fall into three vital areas. First, finding those tiny defects we were talking about earlier. Second, and this is a big one, ensuring worker safety by monitoring things like personal protective equipment.
And third, just general surveillance, keeping an intelligent eye on the entire production process.
Let's start with safety, because this is where the tech basically becomes a guardian angel. Imagine an AI that acts as a safety officer who never takes a break. It can scan the factory floor and instantly recognize if a worker has forgotten their hard hat or maybe isn't wearing the right safety gloves for a task. And this isn't about Big Brother watching. It's about adding a constant, automated layer of protection for everybody. And when it comes to quality control, the impact is just immense. I mean, this AI vision, it doesn't get tired, it never gets distracted, it can spot microscopic cracks, see if a tiny component is missing, or flag a product that's been put together wrong 24 hours a day. And the result is a much higher level of quality, which directly means less waste, lower costs, and better products for all of us.
But here's the thing, this story is nowhere near finished. This is not a static technology. In fact, the pace of innovation here is just absolutely breathtaking, and it's actually speeding up.
Just take a look at this timeline. It shows the number of research papers published on object detection. You can just see this massive explosion of activity in just the last few years. What was considered cutting edge, 2 or 3 years ago, is already being left in the dust by newer, more powerful models. The progress is just relentless. Which brings us to this final, really fascinating question. We've given our factories the ability to see with superhuman precision. So now that they have this power, what new problems are they going to solve? What incredible opportunities will they help us see next?